along a journey of leaving Earth, starting off with the closer things to us that we're familiar with, which are planets. So planetary imaging are our nearest neighbors. They're the brightest in the sky, and they're probably the things that we're most familiar with. The Earth is surrounded by air, obviously, which acts like a fluid. And if you've ever seen sunlight dance on the bottom of a pool, that's essentially what the atmosphere does when we're looking at these planets and the moon. The little GIF you see there is from my camera. This is what Jupiter looks like on a normal New England evening, because our atmosphere is very wobbly. So I have to take videos, and I take thousands and thousands of little tiny pictures. And then I use software that says, this picture is good, this picture is bad. And then I choose the best of the best, and I combine them into one, which is also known as stacking. Apparently I don't need my slides anymore. So this is the moon, our closest neighbor, the thing that we're the most familiar with. It rotates. The cool thing about the moon is it's considered tidally locked, which means as the moon rotates, it's also orbiting the Earth. And its rotation matches the orbital period around the Earth. So we're always seeing the same side of the moon, no matter what. There's a little bit of a wiggle, but that's, neither here nor there. This image of the moon here is actually quite large. It's a mosaic of 15 different images that I was able to stick together. And, the cool thing about it is you can zoom in. So let's zoom in a little bit. This is Tycho crater here. Right there. To give you an idea how big it is, it's 53 miles wide, and it's 3 miles deep. And it was created when an asteroid crashed into it, and the energy from that crash melted all the rocks until it was molten rock. Have you ever thrown a rock in the water and watched the little dupe, whatever you want to call it? That's what that little dupe is in the middle of that crater. It's the molten lava. As it's cooling, it's coming back up, and it's being frozen in time. And it stayed like that for billions of years. And the moon is covered with them. And it's so freaking cool. Last year in January, there was an event called the Mars occultation, which means, it's a fancy way of saying that Mars went behind the moon according to our perspective. I had my camera and my telescope out because I thought this was really cool. And it was one of the very few times that we had no clouds. So this is a single photo of Mars just before it went behind the moon. It was very cold that day. You probably have heard the whole planetary parade, or all the planets are aligning in the sky. So this was the parade from last year. We have Mars, Jupiter, Saturn, and Venus. And these were all imaged on the same day with the same equipment at the same time, within a couple hours of each other. So this gives you an idea of how big they are on my camera for each different planet. And to give you an idea how big Jupiter is, all of the planets in our solar system could fit inside Jupiter easily. Lost my train of thought. It happens. Planets. So we have Venus on the left, which is, right? You would expect it to be a full circle. But since Venus is closer to the sun than us, Venus actually has phases like the moon does. It's also super bright. So I caught this when it was about 90 degrees to the sun from Earth. But as it gets closer to Earth during its orbit, it becomes a very sliver of the planet. And it's really cool. It's really hard to image though. That is a very blurry picture of Venus. Mars, we got a little bit better photo of Mars. You can actually see on the top of it, you can't actually see where I'm pointing, but at the top is actually one of the polar ice caps of Mars. So that's just liquid that has been frozen. And then we'll go to the two favorites, Jupiter and Saturn. The cool thing about Saturn is that its rings are really, really thin, like 30 feet thin at its thinnest. And because it's at a tilt, when we look at it from Earth, its rings will dance. So right now, the rings are edge on. So we can't actually really see the rings, we just see a sliver. But in a couple of years, we'll be looking at the bottom of the rings. And Jupiter, as big as it is, about 9 hours to do a full rotation. So when you image Jupiter, you actually have to take really quick images, because if you take an image for too long, or if you record these videos for too long, you'll actually get motion blur. So like the great red spot as it's traveling across, like you'll get a streak of red because you took too long of a video. So yeah, pretty cool. It's also really cool to see with your eyes. And then there's our star, the sun. It is unimaginably huge. Quick show of hands, did anyone actually go see the eclipse in the area in 2024? Did you all see protrusion from it? So if the length of that red protrusion was about 3 Earth widths wide. So if you think about how big that was in the sky, and imagine how small the Earth is compared to it, it gives you just a sense of how giant the sun is. 1.3 million Earths could fit inside of it. And the other cool thing, it takes 8 minutes for light to leave the sun and reach Earth. So if the sun were to just magically disappear, we wouldn't know about it for 8 minutes. And that sunspot is my frowny face sunspot because it looks like a frowny face. I took that with my camera before I actually did different types of solar imaging, which we will talk about soon. So there's another type of photography that I do, which is more common. This is the natural light photography. So this is looking at objects in the night sky in colors that we can see with our eyes. So red all the way down to violet. These are 2 of my collections of telescopes. The one in the front is a small refractor. So it allows me to look at things that are bigger in the sky compared to the one in the back, which is a Schmidt-Cassegrain, which allows me to see things that are further away by essentially allowing me to look at a smaller portion of the sky. So the one in the back I use to look at planets with because it's able to zoom in, quote unquote. And I also look at a lot of galaxies with it. I take photos of galaxies with it. The one in the front I use to image the sun. And I also use that for bigger images in the sky. And we'll see some of those images later, but I will also be telling you like how big they are in the sky as compared to a full moon, because they're pretty huge. So we have stellar nurseries. So these are called nebula. Can anyone recognize what this photo is? And if you can, just shout it out. No.
Good guess.
Good guess, though.
Good guess, though.
So this is the Pillars of Creation. It's one of the first photos that became like super popular. This is the center of the Eagle Nebula. So nebula are really cool because they're just giant collections of hydrogen gas and other gases and dusts. And as gravity takes in, they'll start to compress and they'll get more and more and more gas. Eventually they turn into their own stars. So those 3 pillars in the center are actually just sheets of gas and dust that are all creating new stars. When the JWST telescope looked at them, you could actually see all of the baby stars in there. And then I also wanted to do a little demonstration because I think this is cool, but I have to take the microphone away, so I apologize. I'll try to talk loudly. But before I do that, so the reason why it's really cool is because this is called an emission nebula. So all of the stars are emitting ultraviolet light and tons of light. And when that light hits or excites hydrogen gas, it causes it to glow. So we know how neon lights are kind of glow just magically because they get a little bit of electrocution. Same type of thing here. And the cool thing is we can kind of demonstrate it with a laser. So I have a laser that's kind of dim and purple, right? And this cool little gel toy that I've had for I don't know how long. But if you shine the laser through the red, kind of doesn't really glow much. Shine it through the blue, you can see a little bit of green. But if you go through the yellow, it's much brighter because the purple laser excites the yellow pigments and causes them to emit light on their own accord, which is pretty cool. I thought about that at 2 a.m. this morning. I apologize. All right. So one of the challenging things about the Eagle Nebula is it's really low on the horizon. So where I live around tons of trees, and tons of trees live around me. So I get like an hour of time to see this every night. So I had to wait for a full week of clear skies to take this image of this Eagle Nebula. And I'll talk about the colors a bit more later, but if you were to look at this with your naked eye, it would look fairly red. There's not really much color to it, which is actually what we're talking about now. So one of the things that you probably, there's a lot of photos that we get from JWST or Hubble are very orange and blue or gold and blue. And it's really nice because it shows things, it highlights different characteristics of what's there, but it doesn't necessarily show you what you'd see with your eyeballs. So the image on the right is called the Cone Nebula or the Christmas Tree Nebula. And I imaged it using 3 distinct filters. One is a sulfur filter, one is a hydrogen filter, and one is an oxygen filter. Sulfur and hydrogen are both very red colors. And oxygen is actually a teal color, like a blue-green color. What we do is we'll take image with a sulfur filter, which shows you like the structures and the turbulence of all the gas and dust and how everything is colliding. And then we map that to a red channel. And then we take the hydrogen gas, which is a red color, and we tell it now it's green. And the oxygen, we're like, yeah, you're blue enough, you can say blue. When we do that, we get a really green image. So then we have to change how those colors blend. So we take a little bit of green and we add it to the red. And green and red and light gives you a yellowish color. So we add a little bit more red and it gives us a nice gold color. But the reason why we do that is because if you don't, the images look kind of boring. So this is the Sol Nebula. On the left is it in natural color, is what you would see if you use your eyeballs. Can't really see a whole lot. It's kind of a pretty red. But on the right is the same thing using this sulfur, hydrogen, oxygen color palette, where I mapped the colors into, or mapped those different filters into that color. So you can see on the bottom, you can see like this different protrusions and structures, and it kind of makes it like, wow, that's really cool. And this is home. This is the Milky Way. This is where we live. This is a photo I took of my friend's house in Utah one night. I just went outside of his house, and the Milky Way is enormous. And it just smacks you in the face with how big it is and how bright it is. And if I remember correctly, this right here is the Eagle Nebula. So that's where the pillars of creation are. I'm glad I brought that laser now. So the other cool thing about the Milky Way is it's enormous. So like the center of the Milky Way is a giant black hole, which is 26,000 light years away, which is really far. And then we're going to start going further out. So we're leaving the Milky Way a little bit, and we're kind of jump a little bit. So this galaxy here is the Whirlpool Galaxy. I took this from home with that giant round telescope that I showed you a little while ago. And this is 25 million light years away. So this is actually two different galaxies that are colliding, but on the scale of how big things are and how fast they move, the collisions are quite gentle. And with how far apart all the stars are, nothing really crashes. They kind of just fold in like a deck of cards. And they turn into like gorgeous spheres. So this is a really cool image for a lot of reasons, because it shows the collision that happens, but there are actually, because the collision is happening, a lot of those gases that we were talking about that make stars are also creating new stars in this process. I don't have the other image that shows it, but believe me. This is the Andromeda Galaxy. So this is probably the galaxy that most people are familiar with when they think about their galaxy other than the Milky Way, because this one is our closest neighbor. It is also enormous in the sky. So from corner to corner, 6 full moons could fit in the sky. And if you're actually in a dark enough location, you can see it with your eyeballs. It looks like a little tiny smudge. We also, people talk about it, but it is moving towards Earth, towards the Milky Way galaxy at 300 kilometers a second. So we got a long time before we have to worry about that. So we're going to talk about this now. Does anyone know what stars are on the screen here? Does anyone recognize anything?
Orion.
Okay. So we know this is Orion, which is great. Now let's watch a little video. Hopefully it works. Trying to show you where things are in relation, and I also added my images too. But when I talk to people, I'm like, oh yeah, I took a photo of this, and this is where it is. I get a lot of blank stares, which I understand. So I'm trying to like walk you through where things are just in Orion itself and the area around Orion. So this is the Horsehead Nebula and the Flaming Star Nebula, and that giant bright star is the left star of Orion's belt. And then if we zoom out, I think we go to Rigel. So the bottom bright star, Rigel, there's this giant reflection nebula called the Witch Head Nebula. And all of the light from that star is going towards that dust cloud and reflecting back towards Earth. That's the only way we can see it. And then if we move over to the other constellation, Monoceros, this is the Rosette Nebula. This is an area that's generating tons and tons of new stars. And it's really pretty. I might be biased. And then we looked at the cone earlier, but this shows you where the cone is in relation to everything else. And we'll zoom out again, and we'll go towards the Monkey Head Nebula. So this one's kind of neat because it actually looks like a monkey head. And it does in my photo too, so I did something right. And then the last one here is the Jellyfish Nebula, which is the result of a star that exploded a very long time ago. So the thing that looks like a brain is actually the result of the star that exploded. And the shock wave from the star is what's causing it to glow orange or glow red. So that's it for that short video. Took me a little while to do that. So we're going to go a little bit into a different territory. This is the newest form of imaging that I am highly addicted to. It's called the spectroheliograph. Let's break that word down. Spectro means it uses a spectrum. Helio for sun, graph to photograph. So we're taking the sun and we're looking at it as a rainbow, but a very, very small section of the rainbow. Kind of like if you look at the bottom of a CD, how it has the different rainbow color on there. I actually have CDs still. That's essentially the same thing as what a spectroheliograph is. It's kind of like a prism, but it's more like a CD, and it has a bunch of different lines on a reflective surface. And all those lines are able to reflect the light and spread it out like a prism would. So on the right, you'll see two different colors. So we have the red one up top, which is hydrogen, and the bottom one is calcium, which is ultraviolet. What these are is when the sun emits energy, hydrogen in the atmosphere absorbs that energy and then re-emits light. But because it's absorbing it and then re-emitting it, it emits it in different directions. So we may not see it, which is why it turns darker. Same thing with calcium. But the cool thing about this is not only does it have pretty colors, but it also tells you about things at different levels of the sun's atmosphere. So red is closer to the atmosphere, whereas the purple stuff is farther out. When I take an image of the sun, I'm really not taking a photo. I'm taking a lot of lines. I'm taking a video of a bunch of lines that just go over my screen, and it looks really cool to me. But it creates really beautiful photos. So this is the sun in hydrogen. So it's really tiny, but because I added other photos of it. So I'm able to take photos of the sun with really cool details. I can then take images of all the sunspots. I can then change over to a different color and look at a different level of the sun's atmosphere and get different interesting ideas from it. So with calcium, it's actually further out in the atmosphere, so you actually can see more of the structure of the sun. And you can also do the same thing with making the sunspots. And those giant sunspots you see, this is all the same day. It's all within 20 minutes of each other of taking the images. But in the middle is that giant sunspot that you can see has these giant noodly-like appendages that come out and go into the other side. So this is all like magnetic field lines are coming out one side and into the other, and all the sun's plasma is following these lines and looping around. And this one is actually why we had an aurora in November of last year. Pretty cool. But this is the reason why I really, really like the spectroheliograph. This is an animation of the sun exploding off one of its limbs, and you can see all the stuff just flying off the side. And that stuff is moving at millions of miles per hour. And again, remembering how small the Earth is compared to the sun, it just blows my mind. I didn't even know that that was going to happen. It was a happy accident. And I essentially went outside every single day that it was clear to try to capture it again, because I was very addicted to find more of these. I actually had it run for an entire day to try to capture it again. And I didn't. And I'm very sad, but I have hope. But another cool thing is, even though you see the stuff on the bottom, there's actually something in the top right as well. It starts to jet out. I wish I had more data to capture what happened from that, but it's really cool nonetheless. So, you may be asking yourself, what do you need to get into this very expensive hobby? Honestly, a phone. I took this phone, or this photo of the Milky Way with my phone on a tripod in Utah in dark mode. You don't need anything special. You really don't. But if you have a camera, you can use a tripod and you can take images of the sky, and you don't need anything else that's special. Just take images. If you know what you're looking for, if you want to take an image of the Orion Nebula, or I don't have any photos of it, I don't think, but like there's the North American Nebula, which actually looks like North America, which is kind of cool. You can do that. You may not get the same result as other people, but this hobby is not really to be better than other people. It's just, what can you capture? I take photos of several targets every year, not only to see what I can do better, but also to see how things change over time, because they do. And it's really neat when you figure that out. You may also be asking, like, can you contribute to anything? Supernova are regularly discovered by amateurs. We got tons of us that are taking photos of different things all the time, day or night. Not really day, but you know what I mean. You can discover new nebula. I have a telescope in Texas, and the group of people there will all pick a region of the sky and just image it for days straight. And with 800 telescopes pointing at the same patch of sky for 3 or 4 nights, you get the equivalent amount of time as taking a year's worth of data. And then you have like the best processor in the world, combine it all together, and then you can actually find new things. And that's really exciting because then you get to name it. Comets are discovered very frequently by people, by amateurs. With us taking photos all over the place, you can look at different things that move in the images. A lot of them are satellites, which is another issue. We can also look at solar monitoring. The animation I showed you earlier of the coronal mass ejection, that's something that you can contribute to data research for people to know how to predict things better, cool stuff like that. But it's also a personal archive. Like I said, I take photos of pretty much the same thing every couple of years, every year. This is an image of a galaxy that's 40 million light years away. So this little bright star here is actually a star that exploded and died 40 million years ago. And I just so happened to have imaged it 2 years prior. So the image on the top is what it looked like in 2023. The image on the bottom is what it looked like last year when it exploded. And it was really cool to see, just because I'm a nerd. We're gonna talk about light pollution real quick. When you look at the night sky, in this area you actually see a little bit more stars, but when I used to live in Boston, you saw like nothing. You're lucky if you saw the moon. Joking. But it is a really big issue for many reasons. But one of the biggest reasons is, 80% of Americans can't see the Milky Way. They don't know what it looks like. I can't tell you how many times I've had my friends message me like, what's that weird star in the sky? Or are we being invaded by aliens? Like, no, that's Venus. It's just really bright, so you can see it in the city. So there's a scale of darkness called the Bortle scale. It goes from 1 to 9. 1 is like pristine darkness, where you don't have to have a flashlight to see because the Milky Way can guide you. 9 is, inner city Boston, where you can barely see the moon on a good day. This photo here was actually taken up in Rangeley, which is a Bortle 2, Bortle 3 zone. So it's actually kind of cool because for the first time when I went up there were so many stars, I got lost. I know where things are in the sky, but when there are, 10,000 more stars than I'm used to, I was like, I have no idea what I'm looking at. I can't figure out where the constellations are. But this photo, if this laser works, this right here is actually the Andromeda Galaxy. I could see that with my eyeballs, and it was really cool. And Topsfield is a Bortle 5, Bortle 6, so it's less light polluted than the city, but still, you can't see as much. You can't actually see the Milky Way. You can try, but you can't. This is a map from Light Pollution Info, which shows the level of light pollution in the Northeast area for the most part. It's really hard to find dark skies here because, you know, we have so many darn cities that are really close. And, you know, we are fortunate that like this area is fairly good. Like Ipswich is really good. They're darker skies than Topsfield. But if you really want to see some really nice night skies, you have to go up to Maine. Problem with Maine is they get a lot more clouds than we do down here. So every photon has a story. Here are some of those stories. This is the Seagull Nebula. This is as our eyes would see it. This is a full red, green, blue image. There's no additive color. There's no crazy filters. This is just how we would see it if our eyes were capable of seeing that much light. This is the Dark Shark Nebula. It looks like a shark, and it's pretty cool. And it actually has a galaxy for a fin. Like right there is a little galaxy that I had no idea existed until I started looking at the image. So the cool thing about this is a different type of nebula. This is called a dark nebula. And the reason why it's dark is, honestly, I'm still trying to figure that out. But I think it's because the nose is dark, which means you can't see anything that's behind it. You can see the stars around it, and all of this like dusty stuff here is all dust that lives in the Milky Way. It's all reflected by stars that are all around us. Some of the galaxies that I've imaged recently, I don't think I have photos of on here, but there's so much dust in between us and them that they actually reflect light from the Milky Way. So they just become part of the photo. And they're quite spectacular to look at. So this is actually a giant portion of the sky that I have yet to successfully image the whole thing because it's like 12 full moon widths in size. But this is the Witch Broom Nebula. This is a thing that comes out in the summer. It's part of the Cygnus constellation. And it's actually the result of a star that violently exploded many years ago when none of us were around. And the cool thing about this is, had this exploded today, it would have been bright enough to see during the daylight because it was that bright. And actually, there's another half of this. So it looks kind of like a weird face. I don't think I have an image of my own here, but this one's a prettier one. So, oh, actually I do. This is the other half of it. It kind of looks like a creepy face to me, but this is the other half of the Witch Broom Nebula. They're in the same part of the sky. They're just separated by a big enough distance that it's hard for the telescope that I was using at the time to capture them both simultaneously. This is the Boogeyman Nebula. And it looks kind of creepy, and it's really pretty at the same time because it's really hard to see when you're taking images of it. I did something kind of cool with it, where we know that hydrogen glows red. So I also took images with my hydrogen filter to bring out the difference between the red and hydrogen. And that's what causes it to look very pink there. So it just enhances it, and it makes it look, that's actually my Zoom background at work. It's really pretty cool. This is two galaxies that are interacting. These are the Bode's galaxy, which is here, and the Cigar galaxy here. They're close enough that the gravity from Bode's is actually affecting the Cigar galaxy to the point where there's these jets here on the bottom and top. That's jets of where stars are being formed constantly at a very, very, very high rate. And all of that wispiness around it, that's the dust between the Milky Way and these two galaxies. So the reason why we can see them is because our Milky Way is so bright that it's actually going that far out into space and reflecting back towards us. And the technical name for that is the Integrated Flux Nebula, which is a mouthful. This is one of my favorite galaxy pairs here. I always image this. It's just beautiful. This here is called the Embryo Nebula. I was going to say it was my favorite photo, but they're all my favorite. I'm a true parent. So the cool thing about this is not only is it just a lot of dust, but this region here is forming a lot of stars really quickly. And if I had a better telescope to zoom in on it, I would be able to show you those better. But in some of the other photos I've seen of it, let me use my laser because I'm not going to jump. So this area right here, there's probably like 30 stars forming right now. So it's really neat. Can anyone recognize this one? The Pleiades, yes, the Seven Sisters. I didn't know that they had such dusty areas around them, but it's very pretty because it's something that you don't really expect. Looking at these with binoculars, if you have binoculars, when it's clear out, I highly recommend going out and taking a look. Not only looking at the moon, just be cautious that the moon is very bright, but just look around. You can see so many things with just a pair of binoculars. And the Seven Sisters, the Pleiades, are really, really cool because it's unmistakable. This here is called the Elephant Trunk Nebula. And a little bit about this is this cool little protrusion here is another section where a lot of stars are being formed. But it's thought that the way that our solar system formed was in a manner similar to this, where our star was being formed in this cocoon-like thing, as all of the stars around it were essentially blasting all the dust away, creating a little window. And then inside there, the sun was being formed, and then our planets. This is another gorgeous thing to look at in the night sky. There's a lot in this image that I have other photos of that are closer up or further away. But to give you an idea of how big this is in the sky, it's the same size as Andromeda, essentially. So it's 6 full moons from corner to corner. So it's huge. I wish our eyeballs could see this without using a telescope. Here's another photo of it, just closer up. Again, you can see a lot of the maybe you can't. Oh yeah, you can. So you can see in the top how it's got the streams that are going down. That's from that star up there pushing all the dust away. And you can actually see its effect on it. And then of course the Eagle Nebula, which is where those beautiful pillars of creation are. So this is the full thing. And I'm going to ruin this image for you because I ruined it for myself when I found this out. But if you look at it this way, these are eyes, that's a nose, and there's the hat. So it's like a woman's face going this way.
Not sure. Can you do it again?
Yeah, it's upside down. So this is the top of her head. This black line is her eyes, her nose. Yeah. Someone posted a photo of it recently and I saw that and I'm like, I can never unsee this. So this is the Triangulum Galaxy. When I mentioned Andromeda, the Triangulum is its close neighbor. I personally think this is a beautiful image of it because obviously I'm biased, but all of the red stuff you see in here, those are nebula in a different galaxy. So we looked at some of the nebula in the Milky Way, but this is one of those galaxies where you can actually see the nebula from here. And to give you an idea, this galaxy is 2.5 million light years away. So we're seeing those nebula as they were 2.5 million years ago. You can only imagine what is going on there now. And then this is the sun, our best friend that, sometimes gives us nice weather, like today. Again, this is the same image that we looked at earlier, but bigger and colorized. And then also comets, because why not? Comets are really cool. They're extremely hard to photograph because they're always moving so darn fast. This is Comet Lemon that came by last year. The trick to taking photos of comets is you have to take a lot of really short exposures and then use a lot of crazy antics to not make the stars blurry. And I also took this right before the sun came up, which is why it's very bright on one side and dark on the other. You're actually seeing like the sun, yeah. And then I'm sure you all heard about the Comet 3i Atlas, the one that came from a different galaxy, or not galaxy, different solar system or different region of the galaxy. This is what it looked like from my telescope last year. The interesting thing about this is not only was it moving really, really fast, it actually has two different tails. So it has a tail that is going towards the sun and a tail that was going away from the sun, which is uncommon. Yeah, that was really cool when I found out that I actually captured it. And then, lastly, I want to just say that anyone can reach for the sky, and you can too. You don't have to have any special equipment. You don't have to have any crazy setup like some of us do. But keep looking up. You never know when something's gonna happen. This is my backyard. This is looking up from my backyard during the aurora, which, I had never experienced the aurora before, and to have it like right over my house was the coolest experience ever. And if you can, and you can travel, I highly recommend going to find dark skies. Go experience the Milky Way. Go experience the night sky as it's intended to be experienced. Because you get lost. You really do. And it's so pretty. And obviously it'd be remiss if I didn't plug the local astronomy groups. So the North Shore Astronomy Club, we got Amateur Telescope Makers of Boston, and we have the Gloucester Amateur Astronomy Club. So I highly recommend reaching out to some of these clubs, becoming members, nerding out with me because it's fun and because we all do cool stuff. The North Shore Club does a lot of star parties in the area. We actually have a couple of them here today that have telescopes that they're going to set up. So after this talk, if you want to take a look at the moon, please do. If you've never seen it through a telescope, it's really cool. You can see Jupiter too. I don't know where it is in the sky right now compared to. Oh, it's next to the moon? All right, well, there you go. Then, two for one special, right? Okay, I think that's the last slide. It is. Awesome.
We'll be ready.
So, that's Brewster. He has one of the telescopes out. They're over by the library staff parking lot. If you can stick around a little bit longer when the sun goes down, it'll be a little bit easier to see, but obviously, the moon is pretty darn bright, so you can see it regardless. With that being said, does anyone have questions? Yes?
How do you feel about smart telescopes?
Honestly, they're great. I had a slide about them, which I think I deleted because I was realizing this is getting a very long talk, but the The C-STAR telescope is probably one of the better telescopes optically. There's another person in the UK who did a very like thorough deep dive in their quality, their optics, and their capabilities. And the C-STAR S30 and S50 are great. I brought the C-STAR with me to Utah and took some photos there that are still on the telescope, and I haven't processed them, but you know, that's how it is.
They cost a lot.
They don't. Well, they're cheaper than some things. I think the C-STAR S30 I think is like $300, and the S50 is like $500. So they're, you know, not absurdly expensive. They're not insanely cheap either, but yeah. But they're really cool because you just set it on the ground and you use your phone. And it's like, this is the one to take photos of, and it does it for you.
A very basic question. How do you get an image? You showed an image of something and 2 years later, the same exact location in the sky. How do you point it so accurately to get it to that?
So the question is, how am I able to like go to the same spot in the sky? So thankfully, I don't have to be that smart to do that anymore. But do I want to go? Yes. So in the early times, there were these extraordinary women at Harvard who looked at plates of the night sky. They looked at negative, or I guess are they negative or positive? They looked at images of the stars, and they realized how to catalog things and how to learn where things are and how to find them relatively by looking at the stars and matching them up. That terminology is called plate solving, and that's what we do now. So I basically tell my telescope, find this target, and it goes to a general direction where it is. It takes a photo. It looks at all the stars, and it says, you're off. Like, you're off by this much. Move. And it'll move a little bit, and it'll take another photo. And then it'll say, oh, the stars are in where they're supposed to be. You're good to go.
There's a lot of information now about areas becoming dark sky, like Dark Sky International, you know, where they're having people put their lights down or at night or something, shining up to allow people to see areas. So Dark Sky International is a good group too, if you want to go to see a dark sky.
Yes, 100%. Honestly, if you can go out west, there's a lot fewer people out there, so it's easier to find dark skies out there. But yeah, the Dark Sky Initiative is huge. If you have outdoor lights, you know, don't have your lights pointing up, have them point down to the ground. Turn them off if you don't need them, 100%. Yeah, my neighbors really love their 2,000 watt outside lights, so you know, I was content with that. But I think there was another question over here somewhere.
I actually have two.
Sure.
One, how did you get started in this and so knowledgeable? And then what do you use to process in stack?
I'll go with the second question first because that's the easiest one. So I use a software suite called PixInsight, which is, you know, you pay for it, but it's really good at what it does. There are free alternatives called like Cyril. One of my friends has written a script to help with processing the data. But once you have all your images stacked, you get essentially a raw file that you can then start to process, which includes, you know, getting rid of the noise, getting rid of light pollution, you know, enhancing the colors. And then how I got into this, I'm a nerd, and I am very curious about things. So I was joking at work today because they're talking about using AI, and I said AI is currently the reason why I'm not sleeping, because I ask it one question and then that presents me with 20 more questions. So I think I went to bed at 2:30 this morning because I had a really interesting question that turned into a very long discussion, which blew my mind. But more seriously, My father had a telescope when I was a kid, and I remember vividly seeing Saturn through it and just like being utterly amazed by what it looked like. It was one of the more impressionable moments of my childhood, is just making that connection of that little yellow dot is that little planet. And then my grandfather is also a science forward person, and he also talked about telescopes and talked about Andromeda. So one of the things that I did recently was I actually gave him one of my photos. I was like, here you go. Yeah.
When you mentioned you used a hydrogen filter,
Mhm.
is that blocking the hydrogen or is it passing the hydrogen?
It's only allowing hydrogen light. So it only permits a very small section of red light to come through. Otherwise, it blocks all other colors. And that reminds me, I actually have little items for y'all, if you want. I was gonna forget otherwise. So I actually printed out a bunch of images that I've taken. So I'll put them on the back out there, so feel free to take them, enjoy them, or, use them as a coaster. I do not, but I can give you one if you want. You want the Eagle Nebula too, right? Alright, so I will put these out back there. But yeah, thank you all for coming. If there are any more questions, feel free to ask. Yes,
Did you happen to take any photos of the total eclipse?
I did. I drove up to Rangeley where my friend lives, and I did the solar eclipse in 2024. And then on Pi Day last year, I did the lunar eclipse from the same location, just 35 degrees colder. And I also had a really broken shoulder, so it was great. Because I drive stick, so trying to drive 4 hours with the stick was really fun. I had to do it for the science, honestly. That's the only reason why. Yes. On these, no. My friend was like, I do this when I do presentations, and I was like, that's a great idea. I'm gonna do that. And he's like, I only do 10. So I started going through 10, and I realized that these are all my favorite, and I'm just gonna have to do another run at some point. It was also kind of a test run because I use CPS, and I realized that they cut things a little bit closer than I expected. So you can still read what they are, but the text is just a little bit cut. Yes.
How do you deal with the Starlink flares in your pictures?
I curse those things all the time. So the good thing about stacking software is it takes averages of things. So yes, you'll have a giant streak in the sky, but you'll have 20 more images where there is no streak. So then if you add up all the values of those images, those individual pixels, the streaks get kind of removed over time. But I do curse them a lot because there's so many of them. Okay, I think I actually sorted these out. So I'll go put these on the table back here. If you have any more questions, feel free to ask. This is one of my favorite things to talk about. So